So let's continue. We're still on solving a system of equation by multiplying. I have this linear system. The first thing I'll do is take it out of the bracket. So what happens when I look at both systems, I look at both equations, and I notice that I can't change only one number. I should have to change both of them, because 2 is never going to be 5 by multiplication, and 5 is never going to be 2 by multiplication. So I would have to multiply 2 by 5 and 5 by 2, so I would have the same coefficient, you see? Same thing happens with 3 and 2. So what do? I think about it. I like smaller numbers. So I'm going to change 3y and 2y. How do I do that? Well, I'm going to multiply 3 times 2 and 2 times 3. You see? Remember, when you multiply, you have to multiply the whole equation. So there's going to be 2 new equations. So 2 times 2 equals 4x plus 2 times 3, which equals 6y, equals -2. Sorry, -2. And now I have 3 times 5, which equals 15x, and 3 times -2, which equals -6y. And 3 times -12, which equals -36. And now I look at it. Do I need to apply a negative number? O sea, do I need to apply a negative number? Well, I don't, because I can off the bat eliminate 6y and -6y. So now I have 4x plus 15x, which equals 19x, plus 0 equals -38, because negative and negative are added and your answer is negative. So now you have 19x equals -38. You solve for x, so you divide by 19. You divide by 19, and x equals -2. Remember, your 38 was the negative. And now what do you need to do? Well, you choose one of the original equations and you find the value of y. So I'm going to choose the first one. So 2x plus 3y equals -1. 2 times -2 plus 3y equals -1. So 2 times 2 equals -4 plus 3y, which equals -1. And now, to eliminate this 4, because I want to leave y alone, I use additive inverse. So plus 4 plus 4. This cancels out, and now I have 3y equals -1 plus 4, which equals 3. Now I divide by 3, and y equals 1. So the solution -2 and